So good afternoon students. Today we will start with the basic block diagram of microprocessor 8086. Actually it is nothing but the general architecture of a microprocessor 8086. In the last lecture we have studied how the 8086 and how the evolution of the microprocessors happen, and right now we are using the Pentium i3 Core i3 7 processor. So exactly there is too much evolution till now, still the generation of the microprocessor 8086. Okay, so today we'll start the basic blocks which are present in our microprocessor. Okay, so it's nothing but program control semiconductor device. Okay, it is a program controlled semiconductor device, that is nothing but the IC. Okay, that is nothing but integrated circuits. Okay, which which fetches from memory and decode and execute the instruction. Okay, I hope you understand the meaning of this. So this is nothing but the program control semiconductor device which fetch the uh, which fetch the instructions, or we can say the data from the memory. It decodes and executes. Okay, so this is nothing but the instructions, and it is used as a CPU in a computer. Okay, so all these things it happen into the CPU. Okay, so in the previous lecture we also studied, but still I will give the some overview. So in the first generation is between the 1971 to 1973. Okay, so in this PMOS technology and non-compatible with TTL. Okay, and 4-bit processor that is having the 16 pin, 8 and 16-bit processor that is having the 40 pins. Due to limitation of pins, signals are multiplex. Okay, so there are very few, or you can say the limited pins in the start in the first generation. Now in the second generation, during 1973. Okay, so after 1973, so new technology was evolved, and that is nothing but NMOS technology. So it has some faster speed, higher density, compatible with TTL. So it present in 4-bit, 8-bit, 16-bit processors, and it has a 14 pins. Now it has the different ability to address large memory space and input output ports. So you can connect it the input output ports. So it has the input output ports as well as some large memory. Now the greater number of levels of subroutine nesting. Okay, so there are greater levels of subroutine, better interrupt handling capability. Okay, so it has the better interrupt handling in capability. So now in your mind the question is happen, or there will be the question, what is the interrupt? Okay, so interrupt is nothing but when many input output devices are connected to the microprocessor based system, one or more than one of the input device may request for a service at any time. The microprocessor stops the execution of the current program and gives the service to the input output devices. This feature is called as a interrupt. Okay, so interrupt is nothing but so current process which is going on, which is stop, and it will give the priority to the another process. Okay, so it is nothing but what the microprocessor stop the execution of the current program and give the service to the input output devices. That is nothing but the interrupt. Okay, now in the third generation, after almost 5 years, during 1978, there is another new technology come into the picture, that is nothing but HMOS technology. Now it has also the faster speed, higher packing density. It has a 60-bit processor, so it has a 40 pins, 48 and 64 pins. So if the pins increases, so it will become easier to programming. Okay, so it has a dynamic real table program. Processor has multiply, divide arithmetic hardwares. Okay, so you can multiply and add, so you can perform the all arithmetic operations on this. So more powerful interrupt handling capability, right? It has a more powerful interrupt handling capabilities and flexible input output for addressing. Okay, so in the fourth generation, during 1980s, low power version of HMOS technology was involved, and it has 32-bit processor. So in the 32-bit processor means physical memory space is 2 raised to 24 bytes, so it is almost 16 MB, right? So virtual memory size is 2 raised to 14 bytes, so almost 1 TB. Support increased number of addressing modes, so there will be growth in addressing mode and floating point hardware, and it is nothing but until Intel 80386. Okay, so after 8086, the in market there will be the 8086. Now in the fifth generation, so right now we are using in the fifth generation, that is a Pentium, that we have already discussed in the last lecture. So Pentium is having the P1, P2, P3, P4 and P5 versions. Okay, so after Pentium, so I already told you that before this there was very boring things, you can just do the documentation in the computer, but after Pentium is involved, or you can say they are introduced, then there will be the, you can watch the movies and videos onto the PC, or you can say the computer. Okay, so now we are going to our main topics today, that is a functional blocks. Okay, or you can say the general architecture of the microprocessor. So which are the blocks which are present? So that is very important block, that is nothing but the ALU. So ALU is nothing but the arithmetic logical unit. Okay, so in arithmetic logical units, it is nothing but computational unit. Computational means you can perform the arithmetic operations, logical operations into the this block. So you can do the addition, subtraction, multiplication, as well as and, or, nor, comparison. All these things you can perform in a ALU, that is nothing but arithmetic logical unit. So it perform the different operations in a ALU. Now next is flag register. Now various conditions of the results are stored as a status bit called flag in a flag register. So there are different flag registers into the processor, and when you can perform these operations into the ALU, then the flag register is a special purpose register. Depending upon the value of result after any arithmetical and logical operation, the flag bit becomes set 1 or reset 0. So whenever there is a different operations performed in a ALU, according to this flag register get updated. Okay, so in further lectures you will come to know how the flag registers can be updated or how it can be studied. So there are different flag registers. So there are status flags, overflow flag, then control flags, trap flags, interrupt flags, directional flags. Okay, so all these come under the flag register. Now next is register array or internal memory. So in the previous lecture we have studied that there is a RAM and ROM. So it is nothing but internal storage of data. It is maybe required for storing the data as well as the instruction set or program. Okay, so this is very important part of your our microprocessor, that is memory, or you can say the register array. So I'm going to explain you how at exactly the memory or register array can be built after the end of this lecture. Now next is program counter. Okay, so in the program counter generates the address of the instruction to be fetched from the memory and sent through the address bus to the memory. So what happened in the program counter, it store the current instruction set address. Okay, the program counter what exactly does, it store the current current instruction address of the current instruction, and when the next instruction execute, the program counter again filled with the next instruction set address. So it generates the address of the instruction set to be fetch. So which instruction we are going to fetch, that address will be stored into that program counter, right? So now next is instruction decoding unit. So it decodes the instruction and send the information to the timing and control unit. Okay, Timing and control unit, it is a section of microprocessor made up of synchronous sequential logic circuit. So you are studied sequential and combinational logic circuit in a digital electronics. So digital electronics is the prerequisite subject for this microprocessor. So synchronous sequential logic circuits which are required here in the timing and control units. It controls all internal and external circuits. So in timing and control unit, this accept the information from instruction decoder and generate the microstep to execute it. In addition to this, this block accept the block inputs, perform the sequencing and synchronization operations. Synchronization is required for communication between microprocessor and peripheral device. Okay, so this is nothing but the work of timing and control unit. It is also synchronize all the data transfer. So this is nothing but the timing and control unit. So it generates the control signal for internal and external operation of the microprocessor. So whatever the internal and external operation you have to perform into the microprocessor, it generates the signal. So it is, we have done with the basic blocks of the our block diagram, or you can say the general architecture. Now there are different bus, you can see the address bus, control bus and database. I am going to take the special lecture on this bus of this block diagrams, or how the internal structures are connected to the each other to the different bus, and why there are a different bus, why there is not a all bus are same having the same bus. Okay, because there are some few, you can see there are few are data bus, few are control bus, few are address bus. Okay, so we are going to take the special lecture on this. Now overview of above lecture. So first, 16-bit processor is released by the Intel in the year of 1978. Originally HMOS and now manufactured using the HMOS 3 techniques. Approximately 29,000 transistors and 40 pin DIP with a 5-volt supply. This is all nothing but the specification of the microprocessor. Does not have any internal clock, external asymmetric clock, source with a 33% duty cycle. Now it has a 20-bit address to the access memory. So you can say the address bus is having, or you can say there is a 20-bit of address. They can address up to the 2 raised to 20, almost 1 megabyte of memory space. Okay, so in the next lectures I will going to explain you how exactly these bits can be, or how the memory can be stored, data can be stored into the memory. Okay, now addressable memory space is organized in two banks of 512 KB each, even or lower bank and odd for higher bank. Now address line A0 is used to select even bank, and control signal BHE is used to access the odd bank. Now when in the coming lectures I will going to show you which are the different signals, they are having different pins in the pin diagram, and then you come to know. Now use of separate 60-bit address for input output map device, and can generate 2 raised to 16, that is almost 64 KB of, or we can say 64 kilobyte of addresses. Okay, so there are different so there are different 16-bit address for input output map, and operant, sorry, it operate in a two modes, that is a minimum mode and maximum mode, decided by the signal at MN and MX bar pins. Okay, there are the two pins into the microprocessor. So that is a minimum mode and maximum mode. Okay, so you can set which pin according to your microprocessor will behave. Now that I will that I already told you that we are going to explain the memory. So into the memory, you know, in a digital electronics you learn that the memory is nothing but what, or you can say the one bit of memory can be stored in a flip flop. So flip flop can store a one bit, right? So you can see there are different flip flops. Okay, So I will taken here, I have taken here actually 7 flip flops, and each flip flop store the 1 bit. So what is meaning of this? Now if you connect these flip flops sequential manner, okay, or you can say in a sequence of chain, there are almost, you can see in the below picture, there are 7 flip flops and they are connected to each other. So it form the register, right? It form the register. Now you can see here flip flop 0, flip flop 1, flip flop 2, 3, 4, 5, 6 and 7, they are connected into the one chain, and this form the register of 8 bit, right? You can see there are 0 to 7, there are almost 8 bits, so it is nothing but 8 bits of register, right? Now how the memory can be built? Now these registers are going to stack on each other, okay? So register 1 stacks on register 2, then register 3, register 4 and register 5. So there are 8 bits, and this 8 bit can be uh, stack on each other, or 8 bits nothing but we can say the registers. These registers can stack on each other, and likewise the memory get formed. Okay, now here I will give the small definitions, few definition which is required while in further lectures. So there is nothing but the opcode. So opcode is nothing but the binary code that indicate the operation to be performed is called as a opcode. Now what is the operand? Operand is nothing but the data on which the operation is to be performed. Okay, so we can say as well as result of an operation are termed as a operand. Now what is the instruction? Okay, so in the previous times you listen the word instruction. Instruction is nothing but the combination of this opcode and operand that can be used to instruct the system is called as an instruction. Right now we are when you are going to write a program, you are write a program in the form of instructions. Okay, suppose I am giving you the instruction and you have to follow that. Likewise, whenever I am going to you are going to write the program in the form of instruction, that instruction has to follow to the processor. Okay, now instruction set. Now the instruction set is nothing but a list of all the instruction that can be used to a system. It is called as the instruction set of that system. Okay, so instruction set we are going to study very vastly in the coming lectures. And there is a bus. The bus is nothing but the a group of lines or pins or signals having a common function in terms as a bus, means we are transferring the data from microprocessor to the input output device, memory or control unit. So this transmission of the data can be done by the bus, and there are 3 types of bus: data bus, address bus and control bus. So these are we are going to study in the coming lecture. So I hope we are done with the today's lecture, and I hope you are watching these videos, and if you have any doubts, kindly message me or write the in a comment box. So thank you very much for today.